Okay, so we're on to the final lesson in Unit 2. This lesson concerns graphing linear inequalities in two variables. So we have graphed linear functions, linear equations in two variables. So this isn't much different, except we are graphing a line and then shading the half plane that represents the inequality. So for our first example, in order to understand these linear inequalities with two variables, we need to understand what a solution is and what a solution isn't. So in example 1, I ask you to check whether ordered pairs are solutions to the given inequality. So this ordered pair 3, 2 is an xy ordered pair. So I would substitute 3 for x, and I would substitute 2 for y. And I would simplify that side of the inequality. 4 times 3 is 12. 2 times 2 is 4. If I keep simplifying, this inequality becomes 16 is greater than 6. This point creates a true inequality. That means that this point is a solution. Okay? For part B, we are testing whether this point is a solution. I'm going to substitute -1 for x. I'm going to substitute 4 for y. And I'm going to say that should be greater than 6. So when I simplify, it's -4 plus 8 is greater than 6. And then 4 is greater than 6. That point produces a false inequality. So that means that point is not a solution to the inequality. So you're substituting the x value for x, the y value for y, and then seeing if that creates a true inequality. So for the guided practice, work those out, try them, pause the video, and make sure that you check your answers and ask questions if you're not sure how I got the answer I got in my work. Okay, so for the guided practice, number 1, I got that it was not a solution because it produced the inequality 10 is less than or equal to 8. That's a false inequality, so 6, 2 is not a solution. In number 2, I got the inequality 7 is less than or equal to 8. That is a true inequality, so that means the point 3, -1 is a solution. So now that we know what solutions are, we can move to graphing. So this gives us the steps to graphing a linear inequality. So hopefully you're referencing this as you're going through, some of the guided practice and some of the practice itself. So it says to graph a linear inequality in two variables, we follow these steps. The first step is we graph the boundary line. So the linear inequality will look like a linear equation. So we graph that like we graph a linear equation. So the difference is whether we have less than or greater than, and less than or equal to, or greater than or equal to. So if I have an inequality that is just less than or greater than, we are going to use a dashed line. So a dashed line is something like this. Okay? For inequalities that are less than or equal to and greater than or equal to, we're going to use a solid line. So that's what a solid line would look like. The way we graph the inequality itself, the rest of the solutions, we test a point that is not on that boundary line. So we pick any point not directly on the line to determine whether it's a solution or not. If it is a solution, we shade the half plane that contains that point on that side of the boundary line. If it is not a solution, if it isn't a solution, we shade the other half plane on the other side of the boundary line. So I'm going to show you that in the next example. In example 2. In example 2, I say graph this linear inequality with one variable. So the first thing I see is it's less than, so that we know that's going to be a dashed line. That's the first thing. And this is remembering back from when we graphed linear equations. This is going to be a dashed line at y equals -1. That's a horizontal line at y equals -1. So I'm going to draw a horizontal dashed line at y equals -1. And I'm going to pick just any point not on my inequality. So let's just pick a point like 0, 0. And I'm going to ask myself, the y value of 0, 0, I would substitute in, which is 0. This creates an untrue equation, so this top half of the plane is not part of my solutions. So that means I would shade the bottom half. Okay? So if that point created a true inequality, I would shade the side of the line with that point. But since this point wasn't a solution, I shade the other side. All right? So moving ahead, graphing a linear inequality in two variables. We look at this linear inequality, a couple things I'm going to tell myself. First thing I'm going to say is that is a dashed line because it's just less than. Okay, it's just a less than inequality. Next, we look at the form this is in. This is in that standard form, so I'm going to find the intercepts. I'm going to find the X-intercept first. I find the X-intercept by plugging in 0, substituting in 0 for y. So this becomes 3x is less than -6. I mean, the inequality isn't as important here. And maybe we're just finding a value here, so I'm just going to use equals. How about that? So then that means that x equals -2. So my x-intercept is -2. So I'm going to graph that right away. My y-intercept is when my x value is 0, so I'm going to substitute 0 for x. -2y equals -6. Y is equal to 3, so my y-intercept is 3, and I've got my 2 points. And I'm going to connect those 2 points with a dashed line. So that dashed line for me will look like this. And it's not going to be perfect, it's not going to be exactly straight, but as long as I see it connecting those points, I'm good. Okay? So from here, we're going to test our point. So I'm going to try and pick an easy point each time. For me, an easy point is the point 0, 0. So that means, and I'll use a different color to test that point. So I'm going to choose the point 0, 0. So that means I go back to my inequality. I substitute in 0 for both x and y, and that's got to be less than -6. So I ask myself the question, is 0 less than -6? No, it's not. So that means I would shade the other side of that boundary line. So I'm going to shade the other side of that boundary line because that point was not a solution. All right? So what I want to do next is I'm going to skip example 4 for right now. I want you guys to just work on the guided practice for 3, 4, and 5, okay? And then I'll explain those. I'll explain the absolute value inequalities in the next video because that's a little bit separate. I want to separate those two ideas for now. So pause the video, work through 3 through 5, and then check your answers with me in a few seconds. Okay, so to explain the guided practice, number 3, it's x is less than -2, so I know that that is going to be a dashed line right off the bat, and it's x is less than -2, so it's a vertical line at x is -2. The point 0, 0, provided it doesn't fall on our line, I think that's the one that's the easiest to substitute in and see if it's a solution or not. So if I substitute an x value of 0 into this inequality, it makes that inequality false, meaning 0, 0 is not a solution, which means I shade the other side of that boundary line. So moving ahead, this inequality is in slope-intercept form. So it's giving us the slope and the y-intercept. So I realized that the slope was -1. The y-intercept was +2. So I could graph my y-intercept and count the slope from that y-intercept. And then again, 0, 0 didn't fall in the line. I substitute that in. It creates a true inequality, which means I can shade on that side of the boundary line. And then for the final guided practice, I realize it's greater than. So I make a dashed line. I find the x-intercept and the y-intercept. By substituting for the x-intercept, I find that by substituting 0 for y. To find the y-intercept, I substitute 0 for x. I graph both of those, connect those dots with a dashed line. I test the point 0, 0. It creates a false inequality, so I shade the other side of the boundary line. So I want you guys to move on. I'm going to have some sort of activity. I know that we're virtual now, so that the practice is going to be hard to graph things. I'm going to try and give you different instructions for the practice so that you don't have to create your own graphs and graph by hand so much. All right? It's going to be more about describing, I think. So you can move on to the next step of the lesson. I'll have you come back and finish the notes for this last example after the next step in the lesson.